Hi, so we are here to learn about how to deploy a smart contract on XinFin network, which is also the XDC network. So before understanding this, let's first understand what is a smart contract, right? So the word smart contracts mean contracts which are smart enough. By meaning it's smart enough, it means something which can be executed automatically. So smart contract is a contract which is built into code. So it is just a series of if and then conditions which are written in a series so that things happen according to the code. So it can be summarized as a business contract built in the form of a program which resides on the blockchain network. Now, the network provides the computation which is required to execute the program. And to execute the function of the program, permissions are provided to designated actors which verifies. So here we'll actually understand about writing a particular smart contract and how you as a developer can write smart contracts which can be scaled to thousands of users. So how can you actually start your journey into smart contracts, right? So how can you as a person can choose in which language that you want, what are the different development environments that you would need. So a smart contract language is a programming language that is either used to write a smart contract directly or is compiled to it. So smart contract languages for XinFin network are Solidity, EVOS, Viper, Ethereum bytecode also works directly. So Solidity is the most popular smart contract language for Ethereum, right? So hence it is also we have also chosen the same language, and here in this video we'll also understand about how Solidity can be used to write smart contracts on XinFin blockchain as well. So to choose a language, there are a plethora of choices which are being available, right? And which can overwhelm anyone new to building a smart contract. So simplifying the environment setup is the first step towards delving deeper into the blockchain world. In order to set up this environment for developing a smart contract, there are two choices which are primarily available. One is to choose an online IDE, which is Remix. IDE here is Integrated Development Environment, or you can go ahead with local setup. So the first choice, if we just go with Remix Online IDE, it is used to build and test smart contracts. This is actually the easiest and quickest and the most recommended way for beginners. And then there's this particular setting called local setup. So if you want to build things locally, there are different options as well. So one is to write your contract directly on an IDE, which is Visual Studio Code. So there's a plugin for Solidity which you can directly install in. The next option is using Node.js. The third is Truffle. So Truffle is another framework which is actually being used popularly, which is used to write and test smart contracts and also deploy it. So the way to install is it directly install from an npm package, which is npm install -d truffle. And there's fourth option, which is Ganache, which you can also download directly from this link. So what are the pros and cons of using a Remix IDE versus a local setup? So in Remix, you actually don't have to install anything. It's completely online. Whereas in local setup, it requires installing some or the other application. In Remix, you can get started without any challenges, without validating the smart contract, anything. You can just open up the link and then start writing the contract. And also there's a benefit that it provides directly a local XinFin virtual network, which you can use from the remix and start interacting with the XinFin blockchain or with any blockchain directly. The pros of local setup is it eases the selection of tools to build up distributed applications. So if your purpose is to build a dApp, you probably would be needing a local setup. However, if your purpose is just to write a smart contract and deploy it, you can probably choose Remix as an IDE. The cons for Remix is when you're developing decentralized applications or dApp, so it would actually be very difficult for you to interact with your application, to interact with different components of your application. However, it is very easy in terms of a local setup. And the cons in local setup would be the environment setup is tedious and it usually takes in a lot of time. So let's understand the different components of Solidity smart contract. So first comes in the structure. So Solidity smart contract, in essence, is a collection of the following things. One is data, which maintains the current state of the network, and then there's function, which applies the logic to the uh, transition the state of the contract. Right? If I am at a particular state, I do want to go to a next state. What are the rules that will define it? That comes under function. So if I'm at state A and I want to go at state B or C or D, this is something which would be decided by a function. Whereas in data, we just maintain the state or we just maintain the current state of the contract, right? So coming next, this pragma directive. So pragma keyword can be used to enable certain compiler features or checks. The statement below defines that the source file will not compile with compiler earlier than 0.4.0 and compiler version 0.6.0. This declaration ensures no unintended behavior is introduced when a new compiler version is introduced. So when you have in versions in Solidity, and with every version there comes in drastic changes. So there is a huge possibility of drastic change coming in a version. Hence, we define the version of the contract so that we want the compiler to behave the way as in the version that we have written on the contract, not the version which is the latest one. The contract keyword is actually declared using the keyword contract. This declares an empty contract which is identified by the name purchase order. So when we write a contract purchase order, this is actually creating an empty contract and it has been defined by using the keyword contract. So in Solidity, we have two types of variables. One is value type, the another is reference type. So in value type, these type of variables are passed by value. That is, they are always copied when they are used as functional arguments or in assignments. For example, integers, Boolean address, etc. And then there's another type called reference type. So these are the types of variables which are kind of complex and are passed by reference. So these variables do not fit into 256-bit and have to be managed carefully as copying them is very expensive in terms of the gas. So how to add data to smart contract? So let's add some data variable to the contract for every purchase order. So in this particular example, we would be creating in a contract which is kind of a purchase order. So if you just see in the previous one, so we are creating a contract which is purchase order contract. So this contract would actually be purchasing something or updating the quantity, and you can use some functions to see the quantity and to get the quantity. So let's add for every purchase order, there has to be some quantity of product associated to it. Let's add a variable product quantity, which will be of data type integer or number. The variable we are introducing now is an unsigned integer and is represented by uint 256. So 256 here signifies the 256 bits of storage. The product quantity is only a positive value, and current assumption is we are going to cater to a very large value for product quantity. The product quantity variable is declared as a part of the contract state and hence is persisted or stored in contract space. So currently this variable will be default set to the value of 0. So maximum value uint 156 can assign here is 0, and sorry, the minimum value is 0 and the maximum value would be 2 to the power of 256 minus 1, which is a very large number. Hence we decide of adding in uint 256. So u here is an unsigned, int is an integer, 256 is 256 bits in size. So now let's understand how can we write in constructor in Solidity. So in current scenario, the product quantity is set to 100. So when the contract is deployed, right, as soon as the contract would be deployed, the product quantity number would be set as 100. A parameterized constructor can also be created by passing a variable and initializing product quantity using passed in value. The key point to be noted here is the access modifier public, which has been associated with the constructor. So public keyword here specifies that the contract can be or this particular constructor function or this particular constructor can be accessed by any function, right? So anyone can access this function and this is not a restricted function. Hence, we have added the access modifier of public. So let's understand how to add our own functions. So functions are controlled capabilities which can be added to any program. So any function is preceded by a keyword function. Overall, this is how we declare a particular function. So function name, access modified, state mutator, return value. So this is the general syntax of a function. So let's just write two types of functions. One is a getter, one is setter. So one of the most common requirements for any program is to read the stored value. In the following contract, we are going to need to read the product quantity value. In order to provide this capability, a read function or a get function is added. In this function, we are not doing any manipulation to the stored value. We are just retrieving the stored value. So function name get quantity, right? So no parameters are passed here. Then the access modifier here is public, which means anyone can access this function. The state mutator is view. This signifies that function only reads the state of the contract. It does not changes the state of the contract. Hence, we are adding it as view. And then the return number or the return value here is it returns a variable of type uint 256. Defined what is declared or what is returned by this function. Now coming to a second function, which is setup. So reading the data is necessary and we have accomplished it in getter. But most of the scenario also requires capability to write or update the data as well. This specific capability is provided by adding a setter function. This function takes a value from the user in the form of an input parameter. Using the value provided to the function by the user, the value of variable product quantity is written to or updated. So update quantity here is the name of the function. It is of a uint 256 value, which is the parameter value of type uint 256 is passed into this function. This function is public, which means anyone can access this function. We don't require a state mutator here as the state is getting updated by the function. And there's a return field which returns a variable of type uint 256. So if we just go through this function, so function update quantity uint 256 value public, product quantity is equals to product quantity plus value. So what we are doing here, we are updating the product quantity variable. So if we just combine all of these and see as a single contract, So this is what we are seeing in Pragma Solidity, the keyword contract purchase order. You int 256 as a variable, which is a state variable, which is and then we define in a constructor which is called with the contract and is deployed and initializes the value of product quantity as 100. Then we have added a getter function and a setter function, right? So this is about writing a basic smart contract. Now let's understand about XinFin hybrid blockchain, why we should consider in deploying to XinFin hybrid blockchain. So XinFin blockchain is basically an interoperable blockchain network for global trade and finance, which enables digitization, tokenization, and instant settlement of trade transactions. So primarily the focus is in the finance side, how trade and finance side. However, this particular network can be used for deploying in any decentralized applications. They have so we have 2000 plus transactions per second, where the average fee is 0.0001 US dollars, and the transaction confirmation is just 2 seconds. So if we compare this with different other networks, so in Ethereum network the transactions per second is 12, around 12 to 15, but in Zenfin it's 2000. The average fee per transaction in Ethereum is 0.13 US dollars, which has now fairly raised. And in Zinfin, it's just 0.0001 US dollars, which is almost 1,000 times less than the Ethereum. And the transaction confirmation time here is just 2 seconds, whereas in case of Ethereum, it's 10 to 20 seconds. So let's just understand this particular URL, which is an explorer of a XinFin network. So if we just go to this URL, so here you'll find all the details about the XinFin network. So wherein you can see the blocks have been added. So there's one block 1 second ago, 3 seconds ago, 5 seconds ago. So there's a block which is being added every 2 seconds. There are transactions which are there. If I just open in a block, I can find all the details as block height, time, hash, parent hash, and the transactions which are present into this block. So we see this particular block is an empty block. There are no transactions in it. And if we just open in any transaction, so this is the transaction hash, and this is the block number to it. So these are the block numbers that this is the block that we are seeing in. So these are the extra data, these are the difficulties which we can see. So it's an entirely explorer wherein you can find all the details of the network. You can find the current price, the total XDC supply, the market cap, block time, total number of accounts on XinFin blockchain, the total number of epochs. Epoch here is basically a group of blocks. So currently there are 21 million blocks which are added in XinFin network, and totally almost like 1 billion XDC has been staked so far. So coming next, so writing a smart contract. So let's just start up with it, Remix. So this is the smart contract that we have written in. Right, so this is the contract that we were talking about: get quantity, update quantity, which was the setter function and the getter function. So this is the XinFin remix, right? We can just search for XinFin remix, and this particular platform is the XinFin remix that we are seeing in. Right, so let's just create in a file. Purchase order dot solve. I just created this file, and then I'll just quickly copy the contract. So I'm just copying the contract here. So this is the contract that we were working on. Yeah. So now we have gotten our contract. So let's just quickly. Yeah. So we just have to go to XinFin. We have to choose our environment as Solidity. Right. So inside Solidity, we have to choose our file, which is purchase order.sol. I'll just rename it to purchaseorder.sol. This is our Solidity file which we have gotten, right? So now we need to move to this section and then compile it. So here, as you can see, we have chosen our version to be greater than 0.4, less than 0.6. So this is the place wherein it has already chosen a default 0.5.1. Language is Solidity, EVM version is compiler default. Let's just quickly compile it up. So as we can see, the compilation is successful. Here you get in two files which are ABI and bytecode. So when we just move in next, so here you can see we have different environment. So what are these environments? These are basically, you can consider them as different sellers on Amazon, and you can just select one to take your things ahead. So for example, here we are choosing an injected Web3. So injected Web3 would actually take in the help of the extension that you have in, and you can actually use this browser to take your transactions ahead. So how to get this extension? So this extension is called as a XinPay, which is very similar to MetaMask as an extension. So you can just go to Google Chrome extensions app store, and you can search for XinFin or XinPay. So you can just add this to Chrome. So now once you have it, and now once you want to deploy this, so it asks for the funds. So as you can see, currently my balance is 0 XDC. So in order to fill my balance on the extension, so this is how the extension looks like. All right, I just move back. This is how the extension looks like, wherein I can select what are the different networks. So currently, since we are working on a test environment, so the network chosen here is XinFin Apothem testnet. You can, however, switch here to move to mainnet, or if you're working on any application which is deployed, you can just put in your RPC port details here. Or if you're working on a decentralized application on your local system, you can use this local host. So now once I've chosen XinFin test network, so I can see there's a field of address here. So I'll just copy this address. I'll go to faucet, which is faucet.apothem.network, and then I'll paste this address. So I'll get 1000 XDC. I'll just request for 1000 test XDC from the faucet. So as you can see, the transaction is successfully transferred. So let me just check my balance. So so as you can see, the balance has been updated. Now we have 1000 XDC in the test network. So I just come back to Remix. I deploy this. Now we have enough funds. So we just have to pay. And you can see here the fees for this transaction is 0.000135 XDC, which is very less, almost zero US dollars. So I just submit this up. Submit. And then you can see it here. We have the contract which is being deployed. So here is the contract, right? So now we have get a function or set a function which is in this yellow color, and then a getter which is in this blue color. So if I just get quantity, So since it's a contract which has been just deployed, and in get quantity we return product quantity. So currently it should return me the number 100. So let's just check it out. Yes, it's returning me the number 100, right? And then I just have to update it. So let's say I'm updating the product quantity with 10. So when I'm updating the number 10, so here I'm providing the value. So the value would be increased by 10. So product quantity is equals to product quantity, which is currently 100 plus 10, which should become in 110. So let's just update it. In order to update, we need to submit a transaction. We just did that. So if we just get quantity now, yeah, it is 110. So this is how we interact with the smart contract. So this is mostly about how to deploy and run smart contracts and how to interact with them. So coming back, so we have talked about the faucet interaction with the smart contracts as well. So this is all about how you can deploy the smart contract and interact with it. And that's it. Thank you. Looking forward to seeing your applications on XinFin hybrid blockchain. Thank you.